what we will do to begin with today is, okay, first, sorry for the confusion that there was today morning on whether we have any session or not. So until we say anything else, we will have sessions on Monday, Wednesday, Friday, 10 to 11:30. If there is any schedule conflict, anything that I cannot avoid, like last Wednesday, then I'll let you know as early as possible and we will reschedule. But since now this has been kind of calendarized, I'm hoping that's not going to happen. Now, regarding that, I have one question. 31st July is a Friday and it's Eid. And now, do you guys have holiday on that day or not?
Ranjit will let you know.
Yeah, Ranjit will let you know.
Okay, great. And I do not trust Sanjeev on this because he told me no, 26th January is not going to be a holiday, and it turned out to be so. So, just to be clear. Okay. So the next thing is, I'll need one more week. So by next week, I will look into all the homeworks and all the lesson plans, and not next week, maybe some of it I will do, I aim to do today, because I do want to give you many tasks related to whatever we have discussed last week, okay? So that, you know, once you see, you can listen to something, you may like it and all that is fine, but until and unless you apply that somewhere, you really don't get a good grasp on it, okay? So that's what the tasks are going to do, okay? That's the aim of the task. So that's what I hope to send you by end of today, okay? And these will be due, some will be due on, let's say, Friday, and maybe some will be due next Monday. So that's there. Now, I should say that till now, till today morning, I have received the word problem assignment from 5 of you, okay? Which is, let's say, a little like 50%. Now, this is a very important task, and those of you who haven't sent it yet, please do send it, okay? What we will do is we will combine them together and create a pool. And this is going to help you in future, both to analyze the textbook, etc., and to assign tasks to children, and kind of help them create problems as well. And this last part is very important. Any learning happens best when it goes both ways, not one way. Typically what we do is we give, the adults give word problems to children and they solve it. But they need to have the reverse experience also, okay, where they create word problems and then they translate that into math and solve it. So that is a very, very powerful thing which has been tried and tested in with many groups of children. So that's something that I think you should do. And it is applicable at the primary level all the way up to when you are solving word problems using equations. Okay, so it's a wide applicability. Yeah, so that I just wanted to mention that. So what we will do is so many of you, okay, again, let me just check and tell. I think, no, this I haven't looked into. Okay, so many of you have shared, you know, questions, issues related to teaching mathematics. And let's start with that. But I think there are more questions which are there. And again, I would say it is less than 50% of you who have shared questions and issues. So I'd strongly encourage others to pitch in. Okay. And Sundar has set up an Excel file, and please use that to please populate that with your questions. Okay. So there's the collection of questions that I've had so far. One is, the first one is, if we arrange it in terms of topic, going from the simplest to more complex. The first one was easy way to memorize multiplication tables. Now, first of all, multiplication tables are something children should construct. And there are many ways of constructing it. You can simply do repeated addition, or you can use, array, or draw lines and, crisscross and count how many intersections are there. So there are many ways to create tables, and tables should be constructed. Now, once tables have been constructed, usually tables of 2, 3, 4, 5 are easier. Okay. Usually children do not have too much trouble with those. Similarly, table of 10, very simple. I don't know if any child ever had trouble with that. And again, it can be fostered. Like if you think about table of 10, it's like 1 bundle, 2 bundle, 3 bundle, 4 bundle. So you can make an association that which they should have already done when they learned numbers and place value. That this 30 is 3 tens. So that the 0 indicate that, there is that it's not units but 3 tens. So naturally, when you are multiplying 10 by 3, we are talking about 3 bundles. So therefore the 3 and then the 0 basically indicates, okay, so it's not 3 units, but 3 bundles, 3 tens, right? So that part comes in. And actually we do use, so table of 9 is usually easy, and many children figure out the pattern. So let me use the video. Okay. So see, table of 9, if I write it like this, there is a pattern that children immediately identify, the tens digit increase and the units digit decrease. Okay. Not only that, they also identify that the tens digit is 1 less than the number which is, which you are multiplying 9 with, and the digit sum is 9. So there are several patterns, and these children figure it out. Many children figure it out on their own. Okay, so that's not so difficult. The table of 6, 7, and 8 may give some trouble, and one way to look at them is you use distributive property, so to speak. And this is something we learned from Jodo. So if you are thinking of, let's say, 8 times 7, you can think of it as 8 times 5 plus 2. Now, 8 times 5 is not difficult. Okay. So, and 8 times 2 is also not that difficult. So you get 40 plus 16, 56. Now you can think about it visually too. if you think about this in the sense that you have 7, right? So 7 vertical lines. And you put 5 of them in one color and 2 of them in the other color. Okay? And now if you have 8 horizontal lines, then you can see that 40 coming from the first part, okay, and the 16 coming from the second part, okay. So that way also a little bit of color, and this can be drawn in a notebook and done with that. So this way you can build up 7 using the table of 5 and 2. If you look carefully in NCERT textbook, I believe class 3, they have discussed constructing table of 7 this way. Okay, so that is something that you need to engage students with, play with. Similarly, for table of 8, you can, if you have, let's say, star times 8, you can think of it as star times 10 minus 2. Okay, so if you have to do, let's say, 6 times 8, you can think of 6 times 10 minus 6 minus 6. So 60 minus 6 will be 54 minus 6, 48. Okay, or 60 minus 12, 48, whichever.
Swati, the first row is not visible for us.
Oh, is it visible now?
Yeah, that's perfect.
Yeah. Somehow I am not seeing my screen in the main part. It's in the top border. So yeah, just let me know if something is not visible. Okay. So that way, play around with tables. But the main thing is you need to construct tables. And table of 5 and table of 10 are easy to remember. So use those and then, do 5 plus 1 or 5 plus 2 for 6 and 7. Do 10 minus 1, 10 minus 2 for 9 and 8. Okay. So these are ways you can, get into tables. It's also important that when we are talking about memorizing tables, it's not only that you always recite tables like a poem. What you really need is that you at random recall how much is 4 times 9, how much is 7 times 6, right? So what you can do is you can do some rapid fire rounds, let's say every day for 5 minutes. Okay. Now there is a thrill in that, and you have to answer very quickly, immediately. So that needs some practice. Okay. If you have Jodo material, they do have some games, etc. on multiplication, something based on tic-tac-toe. Okay, if you have that game, I'm not remembering the name of that, but it is based on tic-tac-toe, mainly deals with the tables of 6, 7, and 8. So if you have that, use that too. Okay. Okay, so that was the first one, which is tables. The next question was fraction addition.
So there is a distinction, Swati, between understanding what the tables are and sort of being able to remember them when it is required, right?
Absolutely.
So it may not be that the children cannot, they don't even need to do that. They can always construct the table even by adding numbers, which is unfortunately what they do. And
but
I guess
that
the first
can be
shortcut,
done a little bit smartly. See,
yeah,
you don't need to always add. See, if you're doing 6 times 7.
Come all the way. I agree. So you can start with 5. You can start with 5 or go down with 10.
Yeah.
That's basically what you're saying, right? Yeah.
Yes,
okay.
And that's what, at least I learned from Jodo again. Use 5 and 10 because these are easier to remember.
Right.
So if you need to do 6 times 7, use commutativity. 5 times 7 plus 7. right? Use commutativity, use distributivity to get there. And this can be visualized with array. Okay,
Yeah.
so let them play with math in a more efficient way, not from basic repeated addition. So you add 6 sevens or 7 sixes. That's an inefficient way.
Right.
Okay?
No, I think that also the children who have difficulty, for example, remembering tables. I mean, especially now we are talking about in 6th grade, right? And so they are probably going to be a little bit poor in calculation as well, in terms of they will make mistakes when they add. So you get what I mean? The solution that we are offering might be more of a problem than a solution for them.
Okay, so that is where practice is very important.
Right.
Just conceptual understanding is not going to cut it at this point, especially if you're talking about this older age group children.
Right.
You need practice.
Yeah, no, I agree. I mean, I was just again getting to that there's no way around it.
No. I mean, think about it. If you want to master anything, okay, from, bowling a googly to learning to play guitar to anything, you need practice. There's no, beating around it. But the thing is that practice should not happen without understanding. See, often math boils down to just practice, and practice will take care of all problems. That's a problem. That is problematic. At the same time, if you say conceptual understanding is everything, that doesn't completely cut it, especially if children are irregular and they have had gaps. They come back from a holiday, or let's say now, right? There is going to be a gap before children come back to school and stuff like that. So also older children. So, I mean, all of that. And so, practice is needed, and you connect various dots. See, in the case of older children, they're also getting a bit into algebra, right? So link things up. When you link things up and they realize that, oh, it's the same thing in different forms, etc., that reduces the cognitive load. Okay. Also, another very important thing, if a child is not good at computation, there is a very high chance that child shies away from math, doesn't sit down to do math enough. And that problem needs to be tackled with lot of encouragement, empathy, and support, emotional support. Okay? Because once children start feeling confident, I can do it, they will start spending more time with math, and that will have a snowballing effect. So that also needs to be tackled. Okay. Okay. Now the next question was, should we move on to the next one? Okay.
Yeah.
Okay. So the next one was this classic where children do half plus half equal to 2 by 4, right? And they do that because they don't know what half represents. They just add up the numerators and add up the denominators, right? Now you have Jodokan stuff as far as I know. So, I mean, bring it to them, utilize it. Half, right? And you have half. Now, when you add half and half, what do you get? So, this kind of things should come in. I'm saying it very simplistically, but once they make sense of what is half and what addition means in this case, okay, then, it starts making sense. And definitely contextualize. Half a roti plus half a roti, how much is that? So meaning making is very important, because when a child does half plus half equal to 2 by 4, that means that child is just blindly doing symbol manipulation without any meaning making. So what we discussed last week now, that step 1 is meaning making. What is this weird two-storied number? Fractions are very weird. Okay, so I mean, this is the only thing that looks two-storied compared to, say, integers. Okay, so I mean, you really need to spend time in making sense of that. And then, okay, so if that is then what does addition mean, etc. Okay. The next question is why half divided by 1/4 becomes half times 4 by 1, or let's say becomes half times 4. Now, I have shared with you that chocolate plate model. So please go through that, okay? Because that actually explicitly deals with it. And after that also, if you have some question, we will look into it. Let me take the opportunity to just illustrate chocolate plate with half divided by 4. So when you have half divided by 4, divided by 1/4, that means you have half chocolate, which is there in 1/4 plate. Okay, so let's draw a plate, and I have been told to do it with dotted lines. And then we split the plate in 4 parts. So that's 1/4 of the plate. Okay, so 1/4 of this plate has half a chocolate. We can put half or you can draw half. Either way is fine. Now we have to figure out how much chocolate is there. The quotient is how much chocolate is there in that entire plate, right? So if this portion has half, then this portion will also have half, this will also have half, this will also have half. And you notice that it becomes half times 4. Okay. That's why I love this model. And it works for whole numbers, fractions, unit fractions, proper fractions, improper fractions. Okay. It works for any two positive numbers, positive rational numbers. Okay. Definitely, I have not tried dividing √5 by √3. So let's not get there. Okay. So try this out, and it's very interesting how it works. I mean, it really brings out why dividing by a fraction is equivalent to multiplying by its reciprocal. And that is where you do need associativity. Okay. And today, early morning, I have shared stuff with you regarding those properties of addition and multiplication. Up to integer, whole numbers, fractions, and integers is published. So, you know, take a deep look at it. As I said, the PPT, you will have to wait for the PPT. I need to work on it a bit more, and I'll try to wrap it up hopefully by, I'll try to do it by this end of this month. Okay. So, yeah. So that was with respect to fraction division. Okay, then there were some more question on fractions, and okay, and I need to understand these questions. So the first question was conversion. I don't remember exactly who sent it, maybe Bhakya Lakshmi. Can you please elaborate what you mean by conversion? You mentioned conversion, addition, and LCM. That's what you mentioned. So I need details on each one of these.
Swati, this is Sundar.
Hi.
It's I think between like proper and mixed.
So between improper to mixed, is that the conversion?
All three types.
No, look, improper can be converted to mixed and mixed can be converted to improper. But proper remains proper.
Yes, exactly.
Right?
Yeah,
okay.
yeah.
So that is one thing. The other kind of conversion can be converting a fraction into decimal and into percentage. That's the third kind, second kind. Both were referred to. So anyway, let's take the improper to mixed, that thing first. This is where your discrete model helps a lot. Okay. Okay. There, back collection joins. Okay. So let's say we have 7 by 3. Okay. And if you take your discrete model, you have 7 counters or whatever, and then you make groups of 3. So that's one group, that's second group, and you have one left. Okay. So that means you have 2 groups. That's 2. And then it is 1 left. So that's the one that comes here. And 3 basically indicates in this model how many per group. So that 3 will be the same for both. The denominator remains the same. Okay. So this is a very simple, easy way to go from improper to mixed. Okay. I'm not saying this is the only way, but this is one way. And you can connect it very closely to the division thing. You divide and, right? So basically when you divide 7 by 3, what you have is quotient. Okay, let me put it this way. You know that dividend is divisor.
So we can't see the bottom part of your board.
Okay. I'll go here. Okay. So we know this. Dividend is divisor times quotient plus remainder, right? And if we divide 7 by 3, we know which is what, right? So now you divide the whole thing by divisor. So you will get this. Then you have just quotient plus remainder by divisor. Okay. And notice this dividend by divisor is exactly 7 by 3. And that is equal to the quotient, which is 2 plus 1/3. Okay. And this is where, when we write improper fraction, see, math people are essentially extremely lazy when it comes to writing. So we just ignore that plus and we write it as 2 and 1/3. So the way we say 2 and 1/3, that automatically means an addition. And this is where it gets very confusing, because when you write AB later on in algebra, there you don't mean A plus B, but you mean A times B. Okay, so it's very important that, you know, all these little things need to be articulated, because when you put 2 numbers next to each other or 2 things next to each other, they might mean different things in different contexts. Okay, so it's very important that is unpacked. So this is when you go from improper to mixed. Okay. Now, whatever is the other way. So let's do that. So let's say you have 3 and 2/5. Need to make fraction. Okay, so you have 3 whole, and these are divided, each is divided into 5 parts. Okay, and there are 2 more parts. So now count how many parts total. 5 plus 5 plus 5 plus 2. Now this is nothing but 3 times 5 plus 2, and that is nothing but 15 plus 2, 17, right? So total you have 17 parts, right? Number of parts is the numerator, and each of these parts are 1/5. Each of these are 1/5. So the denominator remains the same, 1/5. Okay. The same thing can be done with discrete. In each circle you will put 5, 5 things. So again the same thing will work out. Okay. So I deliberately showed you 2 models, the discrete one and the part whole model, and you can use both to tackle it. Okay. Any question on this? Okay. So the next question was addition and LCM. So again, do you mean addition of like fraction as well as unlike fraction? Or is it only unlike?
Bhagyalakshmi, if you had sent this question, you can unmute yourself.
Unlike.
Oh, it's your question.
Yes, unlike fractions are the most troublesome thing when it comes to fractions and to addition, subtraction, and comparison. Okay, so the basic idea there is that they need to understand addition of like fractions first. Okay, so if you have, let's say, 2/7 plus 3/7, that it becomes a 2 plus 3/7, which is 5/7. This part needs to be very, very clear to them. Okay, why it is happening, etc., etc. And basically that they don't add up the 7 also and make it a 14. Okay, and why that is and all of that. And this is where manipulative